All right, so before we get going with the show, let's talk a little bit about the Mike Driscoll Python pop quiz for this edition of SacPy. So number 65, modifying lists. What is it? What is the output of this code? Loops equals what? Answer A plus loops equals 2. Answer A and then an exception is thrown, or none of the above. So we're starting with a single entry in a dictionary. We're naming animals, the key being the integer 1 and the value being the string Python. Loops we're setting to an integer value of 1. And so we're going for key in animal. So key in animal. So first iteration on that loop, which we should assume is just going to be one round. Delete animals key. Okay. And then animals key. All right. So key, the value in that first iteration, I guess, is 1. So animals key plus 1. So animals 2 equals none. And then print format string loops equals blah. Okay. So any preliminary guesses before we go to REPL to check this one out?
My first instinct is C.
All right, you want to talk through that for a minute?
So we have animals at 1. We iterate through, we find that key, but we deleted it.
Right. Well,
and now we've set it as +1 to none. But I don't think none's proper variable in that case, is it? And that's why I think it throws an exception. So I wouldn't think none's acceptable.
So delete animals key. So I guess this one's really testing us on our understanding of the delete function for dictionaries.
It is.
And then loops.
Well,
Oh,
I agree with Evan, but for a different reason. But let's hear what everybody else has to say.
anyone else? All right, well, I'm going to switch over.
Woody, I figured you were running late, so I took the liberty of typing it up for you. If you would like me to share screen.
Oh, yes, by all means. Let's see, how do I stop sharing? How do I get out of this? There we go. All right, go for it, Dan.
Do I need permission to share the screen?
I believe you should be okay.
Nope. I'm clicking the button and nothing is happening.
Oh, that sounds like a DN problem because it does.
Oh, he is a problem. Yeah.
Well, Alex was able to share, and clearly I was able to share. So,
Yeah, and I'm also able to share.
well, in any case, I do have a REPL typed up, so I will switch over to that.
You're just trying to make me feel bad now, aren't you?
I think Zoom is trying to make you feel bad, not me. I just want you to be.
That's quite likely.
All right, so Zoom.
It tells me I can't share while you're sharing, but it won't let me share when you're not sharing or something. Isn't that nice?
I certainly. Wow, that's weird. What flavor of Linux are you presently on?
Fedora.
Yeah, okay. Yeah, that's the problem. Fedoras were big in like the what, 60s? These days it's you know, a little too anachronistic. All right, so
Moving right along.
all right, so we got animals. Yeah, I'm sure this is typed in accurately. Wait, typed accurately, not typed inaccurately. So animals 1 equals Python, yeah, loops, yep, cool, 4 key animals, yeah, cool, keys. Okay, I think this is what we should expect, so let's let her rip. Dictionary keys change during iteration. So I guess that's what C.
Oh yeah, I guess because
But it's in line 1.
but there is no line 1.
I mean, animals, I guess, is line 1, right?
No.
Unless you do the standard module or something. Huh.
I
Hmm,
I think that's a misdirection by the REPL.
yeah,
I thought the problem would occur at what we think of as line 3, the for loop, or that it would occur somewhere around the next line,
right. Now,
But in actual fact, it's gone all the way through the loop once, and then it crashes at line 3, the for loop, the for statement.
I wonder if my version Python 3.9.12 is causing an issue.
Who was saying who is anachronistic?
Yeah, right.
Okay, so the problem is illustrated there to explain. Direct dictionary keys are changed during iteration. You cannot change the dictionary keys in the middle of a loop and expect the loop to survive. So
Oh,
at
yeah,
first, when I looked at ABC, I thought, no, none of them are right because C looks right, but I couldn't imagine that it would go around the loop the first time, but it does. And then, so my explanation is it goes through the loop the first time, and then when it gets back to the for statement, it tries to iterate, realizes that the dictionary is no longer the same as it used to be, and then puts up this complaint that the keys have changed. And I'm not going to play with you anymore.
right. Yeah. So yeah, okay. So he's testing us on our ability to recognize that this loop we've created is in that dictionary, and we're messing with the keys. So it's like breaking it. And so maybe that's some sort of safety mechanism he's highlighting. Because I think you could probably do this in C and like maybe, I don't know, overwrite a whole section of your memory or
Well,
something.
yeah, in C, you're messing around with pointers. So you're really asking for trouble if you try and do that, because if you start with a dictionary, in this case, one, or you start with a structure, which is in this case one long, and then you try to go to the second one, you're going to be in trouble anyway.
Yeah.
So, yeah, who would want to use C? Right.
Yeah.
But in actual fact, did you notice there's another test here?
Okay. Another
You,
test.
you, you go back, yeah, you go back to the original question.
Right. Probably the F string.
No, that's fine.
Oh, that was fine. No. Okay.
Is it the comment?
Yes. Well, the name of
Yeah.
it. Yeah. There you go. You see, some of us are awake, even though it's
Some of
even
us
though
are
it's tomorrow.
as other people.
Oh,
Modifying
see,
lists.
It's called modifying lists. No, there isn't a list in sight.
oh, so this is actually a job posting. Mike is looking for an editor. Nice.
There you go. 2 quizzes in one. Yeah.
Awesome. Well, I'm confused, quiz. I mean, Mike, thanks for that quiz. All right. All right, there we go. Here's our meme for the month. Cannot compare float and int. Variable is variable. That, of course, is Mr. Incredible from Incredibles 2, I think, when he's trying to teach his son new math or something silly like that. Good times. All right. Enough with our opener. Welcome, everyone. It is the September 5th in the Pacific time zone, and September 6th in Auckland, edition of Sacramento Python. I have no idea what number this is, but it's been a few of them. And over 1,700 Pythonistas. Imagine a screenshot showing how many there are on our meetup. I think it's something like 1774. I apologize for the mind's eye exercise. I just got in from a vacation that left me cleaning things, and realistically, I'm going to be cleaning things for quite a bit longer, and I missed this one. Oh well. All hail Josh Miller, our glorious founder. He got us started in February of 2017, then passed the torch to me in January of 2020. It's been fun doing things on Zoom, though there was that whole pandemic that was the cause of it. A lot of people have said, hey, let's do things in person again. Let make SacPy great again by making it hyper local. No, we're going to stay on Zoom. We will do some in-persons, and we have done one, and we'll probably do others, but that's more like social mixers. We go, get some barbecue and some beers and, give some high fives or something. But it's nice to be on Zoom so that we can be doing what we're doing now and letting people beam in from literally anywhere. So we have not had any issues. This is the code of, or we have not had any recent issues. This is the code of contact provided by the parent group SacTech. They're a parent group insofar as they create a Slack, and they've, allowed various groups like SacPy to host a channel to discuss, when they're meeting and stuff. So we're inclusive, be cool. If not, expect the ban hammer. So meeting format is pretty straightforward. Unlike in-person large conferences or seminars, we like to not hold our questions till the end. Please drop in line. Use the raise hand function if you're feeling shy, or chat if you are feeling like we might want to do a callback to what you're saying, or just if you're feeling good about managing the airspace and a little, if I may, and then be invited, and we'll get your comment in line. But generally, when you turn your microphone on, please be conscious of what's going on. We would prefer not to have any sound bombing. In the past, we've had some people that did it intentionally. We've also dealt with some people that just generally haven't been super strong on their mute awareness, or rather unmutedness awareness. And I'll try to stay on top of all of that, but you've been warned. So we've got a number of chat channels. I'd recommend taking a screenshot right now and then maybe jumping in later, but I'll type the links in here. That SacTech is the Slack, and www.sacpy.org will jump you into the Discord. SacTech hosts the Slack, and my company, Brazen Studios, hosts the Discord. I'm Woody in both of those, and if you add me, I will probably respond relatively quickly because I have a pretty deep background in online community management and pretty good at the kung fu of, someone sent something long, speed read it and send something back that's hopefully brief and accurate. We're also on Twitter. I haven't tweeted in a week or so for reasons, but it's definitely been great. We pulled the Mike Driscoll Python quizzes from there. And I also tend to tweet to, Python luminaries and say things like, hey, would you like to present? And then we get nice options like next month, October, the Python image library branch Pillow is going to be releasing a new version, and we will be having the founder and owner of that repository, that tool set, presenting in addition to my quarterly update. We're on Reddit. I mostly just post the YouTube videos here. And let me tell you, it's been a lot better since Reddit did some changes to their bots. In the past, they were scraping Zoom links and we were getting all sorts of salty folk. And I really would do a verbatim read through on the code of conduct, especially the following month. Just like, all right, please, like if you're gonna waste your our time, you're really wasting your time because I'm gonna edit this out. You're not gonna end up memorialized on the YouTube. So forget about it. We're on Facebook too. We got a page, we got a group. It's pretty okay. It's more like just a alias for, you know, pasting all the same details. And on LinkedIn, we have a group. Just look us up. SacPy. Yep, there's a group, there's a page, and again, same details are getting posted there. All right, so this is the main one, I think, at this point. Raisin Studios, my company, is the host of the YouTube playlist, SacPy, or it's just Python. Or I think it's maybe California Python, because I'm realizing Sacramento Python is not exactly apropos anymore. We have people from all over California. I don't know that I necessarily want to keep going up in supersets just yet. But yeah, maybe Pacific Pi could be a thing because we get people from Auckland and we get people from the Philippines. We've had Japan. We've had people all up and down the western coast of the United States. But we also have people even further east in the US and frankly, all over the place. World Pi. I think it's just Python at that point, but we're not the Python Software Foundation. We're just a monthly meeting. All right, so we do a kind of Brady Bunch photo wherein we invite everyone to turn on their video camera at this time and, you know, put on your bells if you like. So I'm going to drop the share so I can look at that view. So far, it's just me and an agave with an invisible and Quellen in front of it. Well, I'm looking awesome, so yay. All right, thanks for playing along, people. On to the next one. Oh wait, did more people just do the thing? Ooh. Oh, cool. All right. Do something awesome. Oh, there's Alex. All right, cheese on 3, 1, 2, 3. He's walking away. All right. Pick a sight gag. All right, I got you. All right. Wait. One. Yeah. Please, further ado. All right. Up next. Did I do that right? I don't know if you guys noticed, I updated that little watermark Python. Before it was some wacky straight lined one, but this is more akin to the actual Python logo. So today we have Alex with us, and she is going to be talking about Jupyter notebooks. And I understand she knows a little bit about how to make those things useful for you. If you're not familiar with Jupyter notebooks, it's kind of a REPL type environment where you can go back and edit previous lines instead of having to type them again. And yeah, so I am going to drop the share, and Alex, it is your time to share.
Awesome. Thanks very much.
Well, thank you.
I'll probably will turn my video off in a moment, but I'll just sort of say hi so you can put a face to a name. I'm also beaming in from Auckland. If you are, there might be some overtones as well of UK in my accent, which is a little bit all over the place these days. But I've been in New Zealand maybe nearly 10 years now, so quite a while. I've been working for the past 3.5 years now at a company doing kind of AI engineering, so working a lot with the data science teams help, hence ending up doing a lot of work with Jupyter notebooks. This will be kind of pitched at an assumption of you're not really familiar with these at all, so we'll kind of go over some of the real basics and then go over a little bit how we can make them easier to work with when you're kind of working in a collaborative team environment. I did prepare a repo, which I'm going to paste the GitHub link into the chat. So if you are at home and you want to kind of clone this and have a play around with some notebooks, feel free to do that. I've set the repo up in a number of ways. That it is set up as a poetry project. That's just kind of our like package management of choice. But what we're also going to be doing is going through Google Colab, which is kind of, you can just take the notebook file and upload it. So that probably is, if you do want to try and follow along at home, that's probably the easiest way to do it without worrying about kind of Python environments and all of that kind of stuff. So I am going to now share, hopefully, the correct screen. All right.
All right.
So yeah,
I see your GitHub.
nice. I will leave this up as you can also kind of have it as a reference to go back and look at if you like. So in here, yeah, there's just a readme with a bit of instructions about what we've got in here. As I say, I have set it up as a poetry project, but don't worry about that if that's not your jam. And the main thing is under this notebook example directory. If Go will open this. Oh, it's going to be really slow, just to annoy me. No, anyway, that's okay. When you have checked this out, if you can run this, say with poetry, you can run it with Anaconda, you can run it however you prefer, kind of getting a Jupyter notebook up and running. That will open something that looks a bit like this in your browser, like a file listing. So you can, in here, obviously view all of the folders within your repo, all of the files that are there. You can obviously do like open, download, rename, duplicate, delete, all of that kind of stuff. Over here, it will give you options for creating new things. So you can open a new terminal window if you want to. Create a new Python notebook, just a new file, any file, like a .py file, a .txt file, whatever you want, a new folder. You can upload files here, and I could just kind of like refresh the file list. We are going to jump straight into this notebook intro one, which is a very small, close these tabs, a very small, it's not got very much in it at all. So possibly the world's simplest notebook. At the top, I've just dropped a bit of text about notebooks, because I think a lot of people, if they're not used to, this is a tool, they're kind of like, why do you want to run code in the browser? Like, it just doesn't make any sense to a lot of people. But as we kind of alluded to before, it's a very easy interactive environment for kind of updating and running code as you go. There's two main different types of cells that are in here. If I double click on this, you can see I've got a markdown cell here, which is obviously got the two titles and then my bit of text, which will just present out as a nice bit of text. A lot of like data analysts and data scientists will kind of compile a notebook and then use it for storytelling. So they'll kind of share it with other people and they will put their code, but they'll wrap around it this kind of explanatory text about what's going on, which makes it really useful for telling a story, and for data analysis, if you have lots of visualizations and that kind of thing, this makes it really useful so that people can really understand what they're seeing. So yeah, as I said, it's used heavily for data analysis. A lot of data scientists, if they're working in Python, like using tools like this because they can just really dig into the data that they're saying, but also kind of run different POCs of like small, simple models that they're trying to build. So kind of creating some really lightweight POCs for their models. because of the nature, I think you'll see this as we go through the examples, it's kind of quite easy to end up with code that isn't necessarily so tidy. Like it's not going to be a nice, tidy, broken down modular thing that you really want to put into production. It can often be quite messy, dare I say hacky, at least to start with, while you're getting grips with different data sets and different models. People then go and tidy it up as they go. But yeah, it's a tool that is useful for that more on the go thing where you're just literally digging in. I've put in here some instructions for if you are running this in Colab, just so you get access to some of the files that we're going to be looking at. It is a similar kind of environment. It offers all of the same functionality, but it does just look a bit different. If you are wanting to try things out in Google Colab, just kind of search for that. You'll end up on a page that looks a little bit like this. And if we go to new notebook, I'm hoping that I can do this all smoothly and not confuse myself. I didn't register when I volunteered to give a talk on Jupyter notebooks that I couldn't really get away from live demos, which is every presenter's great joy. So I'm going to upload a notebook. I'll see if I can find this in here. Why did you say leave the site? All right, so yeah, here we can see kind of the exact same thing, but it does just look a little bit different. We'll walk through that in a minute. I've put in a helpful, well, I say helpful, but it might not be really necessary, just thing for if I'm say running in Colab, and it'll just run a few extra steps. I've got another notebook with some more examples in it. One of the first things that we need to do in Colab, though, to get some data files is we need to upload an additional zip file that's got the other dependencies in it. To do that, we do need a runtime. Over here, you can see it says connect. We're not actually connected to a runtime that will actually run any of this code. I'm just going to click connect, and that will set up a Python runtime in the background. And while that is doing that, if I go over here to this folder on the right, this is where we can kind of see the files that are available to us. At the moment, it's nothing. Once it's decided that it's giving me a runtime, it's going to give me the sample data folder, which is just Google just trying to help you out with, here's some examples and some data sets, and you can just dig through those and have a go. We're going to use this upload file here, and I'm going to upload this zip file that is in the repo. This is just warning me, because I'm on the free version of Google Colab, these are kind of ephemeral environments. It's not going to stick around. If you save your notebook in here and then you go away and you've set up a whole bunch of files that you're relying on, they won't be there the next time that you come to use this. It's just something to be aware of. So I'm just going to say, okay, that's uploaded that there. So then if I run this cell, this is going to, because I've set this to true, this is going to unzip my upload file. I'm going to hit this arrow here to run it. Ta-da! And then hopefully this, if I refresh that. There we go, we've got some data. Now we can continue as we would do with the local notebook. So this is the world's most simplest notebook. As I say, we've imported just NumPy and pandas. And I've got a couple of sample data sets here. This one is just the download from the New Zealand police website, where you can download the last 6 months data of stolen vehicles. So I was like, oh, let's go and have a look at who's been nicking things in New Zealand. And it looks a little bit like this. So just an ID column, the color, make, model, year, type, the date it was stolen, and then the location. So lots of different places in New Zealand. And then as an added bit, there's just some vehicle categories. This is the type is the most granular that this particular data sets go to. So they have saloon and station wagon, and these are all kind of types of car. So I've just added an additional data set for the categories. so I can wrap up everything into car or trailer. So with the notebook cells, the last line is kind of what's reflected out onto the page. It's a bit prettier than a print statement. So just by reading here, this CSV file into vehicle cats and then putting vehicle cats as the last line, that is what it prints out to me. So I can just go and have a look and be like, oh yeah, heaps of things. I'm going to switch back just to this local notebook. Here it's a little bit different. We don't have the arrow on the left, but I've got an arrow up here, so I can run these cells. It doesn't going to do any unzipping, obviously. Import NumPy, import pandas, and I get the same thing. So I think already kind of you can get a feeling of why this kind of style of thing is so useful, just because you can get, for each line, you can view it and see the state of your data. It's very visual, it's very interactive. So I'm just reading the chat. A 95 Cherokee, by the way. There's some really funny things in this data set where I was just like, what is happening? Okay, this is where we get into the live demo bit. This is where I'm going to start probably forgetting how to type, and I might end up switching to my other notebook. Just take a look. So I'm just going to do some, oh wait, cats is they're really small. I'm going to do thefts. Just some very basic, just kind of checking of what's going on in this data set. So obviously the D types in a pandas data frames are telling you what the types for the individual columns are. Object is kind of generally what you see when there's a string. So we just got 2 int types. Dates stolen is an object, so it's a string. Probably we'll want to turn that into an actual datetime object just to make it a bit more usable. To add a new cell, there's this plus button up here. Colab just has, I think, a plus code or plus text, depending on if you want a code or a markdown thing. Here I can see it's the code type. There is also this raw one, which I've literally never used, but I think it's just kind of whatever you put in here, this is your output. I think people who use these notebooks for like latex documentation and other things like that will use that. I've never used it. If I do thefts, I've forgotten this thing already. That's it. No. Okay, I've forgotten how to live code, which is absolutely fine. So what I'm going to do is go straight to my annotated notebook example, because I really hate live demos and they always go wrong because I literally forget how to type when I know people are looking at me. So this is the same. We're looking at the same data set. I've just added a little bit more structure around it and some more examples that are already running in Google Colab. It's easy to just, oops. Where's my Colab one? Here. Just go again, file, upload notebook, and you'll just get the other notebook. If you are still in the runtime, you'll still also have these data assets available. So one of the things that I found is when you're, if you're merrily over here and you're kind of adding in loads of text and you're having a great old time digging into your data sets and maybe plotting some things out, it's very easy to get something that's really hard to follow. And especially if you're trying to hand this notebook over to someone else to read later, it can just get very confusing very quickly, and you could lose sight of what is a kind of important moving part in the code versus what is someone just digging into the data set and trying to work out what's going on. So I always encourage people to put in markdown cells, put in kind of examples of or descriptions of what the notebook is actually trying to achieve. So here I've kind of done a bit of summary of what we're going to be looking at, which is the stolen vehicles data in New Zealand. We're going to do a little bit of basic data analysis, and this line is a lie. I took this out. Ignore that. Pretend you didn't see that. A little bit of kind of data visualization stuff. Being the I'm trying to be a good citizen of my data science team, so I'm literally noting like, where's my data source come from, so that other people can tell the context of the data of where it's come from. Because I've had a little bit of a dig through this data already, I've already noted a few things that someone else coming along later will want to have a look at. Like there are some of the vehicle makes and models are missing or they're misclassified, which I've left alone for this demo. But if you're actually trying to do anything real with this data, like build a model off it, then you're going to have to obviously handle that in some ways. Obviously the data only spans a 6-month time frame. So if you're trying to draw a conclusion over like how the thefts in New Zealand change over time, it's kind of, you're only getting a very limited window. So for someone trying to build off my notebook as well, we would have to work out how to handle this, like the erroneous and missing data. If we wanted to do something a bit more interesting, kind of comparing the number of thefts to the number of cars that are actually in New Zealand is a lot more useful than just looking at like the list of stolen data types themselves. Similarly, kind of looking at population counts for the areas where thefts have happened can also make things more interesting, because then it's kind of like just high density areas kind of play into this.
Alex,
Yes.
would it be possible to increase the font size a bit?
Oh, maybe. Right
Looks
click.
like you're on an Apple, so I think if you do Command Plus,
How big can I make this?
that's
This is not
already
big.
better. And then that top right corner on the row of the tabs, maybe hit that down caret thing, very top right on the tab row. Yeah, that thing. Oh wait, never mind.
Don't look at all my scary open tabs. Yeah.
Yeah, it's stressing me out. I'm just kidding. No, it's fine. The font increase is much better. Thank you.
Oh, okay. Thank you. Cool. Yeah, so that's kind of a bit of a summary at the top, just so that when someone is picking up this notebook, they got an idea of what we're looking at, what's missing, what we're trying to achieve here. These headings actually also do make it easy to kind of collapse sections is the word I'm looking for, which is also handy if you have really long notebooks and there's like a bit at the top that is data analysis, and then a bit in the middle that's like some visualization, and then a bit at the bottom, and you want to look at what's happening at the top, but you're already at the bottom, and then it just saves you scrolling if you can easily just collapse sections. So this is an easy way to let that happen. All right, we're going to run through this one, which hopefully is going to not error at me. Done the collab stuff, and we're loading up thefts. Oh, okay. Now I see what I did wrong before. So I've got my data types. This is what we just looked at. And then my brain blanked on it for the next thing that I wanted to do, which is look at describe for the data frame. So here we're looking at the numerical columns. It gives you a bit of an idea of the spread of the data. So the mean, the kind of 25%, 75% quartile. The idea is obviously it's just an incremental column. It's not interesting at all. The year is where things start to get a little bit more interesting. So we've got 2001 as the 25%, 2013 as the 75% quartile, but our mean's down at 1996. So either there's something weird in the data, or there's a lot of people with some very, very old cars in New Zealand that people are nicking. If we do here include objects, we get a bit of a summary of the text-based columns. I did quite laugh a little bit when I saw this word, because us Kiwis love a Hilux. So there's a lot of Hiluxes out there. There's also a lot of people who live in Manukau region. So I was like, oh yeah, maybe don't own a silver Toyota Hilux. Or look after it and don't park it out on the street. This is obviously, these are just showing you the top values for each individual column, rather than literally telling you that silver Toyota Hiluxes are the most stolen, but it's just interesting to have a look at. And the next bit, we're going to get into just some very basic playing around with the data. So this next one, we're just adding in some date features. So here we're turning the string that was the date stolen one into an actual date time object. So then we can kind of pull out things like the month and convert it into like day of the week, numeric day of the week, the day of the month, the week of the year, and then is it a weekend or not? So here we get all of the extra columns added in. One thing that quite often trips people up with Jupyter notebooks is this is updating the thefts data frame kind of as we go. It's one of the strengths, but also one of the things that trips people up is that when you run, say if we go back up here and we look at these data types now, we're in a cell kind of further along, and so our human brains were just like everything logically runs in order, but actually we've updated it. So when we come up to this earlier cell we've already run, we get a different output because we've changed some things. Like here's our date time column. It's not too much of a problem with these things because we're just printing out some data. But if you get into changing data frames, like you've deleted a column or you've renamed something, and then you get confused with your cell ordering because you're jumping around in your notebook a little bit trying to get your code to do what you want, you can end up in a situation where if someone else checks out the notebook fresh and they follow it literally cell to cell from top to bottom, they'll end up with an error because you've just lost track of the fact that you amended something in a later cell than you thought you did. So the whole state thing can cause some confusion. I think what I'm trying to demonstrate that is here, where I'm arbitrarily, for demo purposes, setting a month location total sum for how many vehicles for each location were stolen and just adding that back onto the data frame, and then I'm renaming a column. So if I run it for the first time, we get a month location column. So we know that county's Manukau for month 7, there are 109. But then if I rerun this, because we've changed location, this is going to now complain at me. So what is kind of a good practice with these things when you're saving a notebook and then you are trying to share it with some other people is kind of clear the whole state and then just check that you can run it literally cell to cell. Under this kernel here, if this will open, there we go. This is the same as runtime in Colab, but we have options here. We want to restart the kernel and clear all the outputs of the cells. We can restart it, run all the cells up to this point, or just restart it and run all. So I quite often will just like to restart it, clear all the cells, and then just literally rerun it and make sure I haven't done something a bit weird like I've done in the cell. Okay, you can also collapse and expand the output of these cells. So here we can kind of, if we want to look at this delightful, the full error message, we can do that, or we can kind of collapse it back again. This can be useful for when you're viewing the larger output of the data frames. This blue one over here will literally collapse the whole cell, so you can just really shrink it down. It does look a bit different in Colab. I keep picking the wrong thing. Here you have the option of just this one where it's kind of show hide output. I think it will still do the collapsing based off markdown headings, but they don't have quite as much flexibility with the show hide stuff. I actually do want to upload my other notebook. This one. So I think I have saved some things. I go down to here, I go to runtime. I can also, when I've selected a cell, also select to run all of the cells before, run this one, or run all the ones after. Again, it just looks a little bit different in color with some slightly different options, but it's essentially doing the same thing. Here you can kind of see the circling thing around the arrow just to show that it's doing something above. Can I also make this a bit bigger? Sort of. Oh, okay. It did, when I updated my notebook, it did clear my zip file. Let me just redo that. Yeah. And the other thing while I'm here, I should actually mention, in Colab, if you do want to have files hanging around more often so you don't have this issue of like needing to upload stuff all the time, they do easily let you mount your Google Drive. I think if I just hit this button, it will automatically add a cell and fill it in for me to just say, hey, I want to mount the drive. I think you can also specify subfolders if you only want to mount certain parts of your drive. It does bring you up like a prompt window for selecting permissions. And I found that although it looks like you can select certain permissions that you want to give it, it'll only work if you kind of give it all the permissions that it specifies on that prompt. but this will at least mean you can have files that live in your Google Drive the whole time, and then you don't need to kind of keep worrying about this uploading of files because your runtime has gone away. Oh, so there we go. Got our runtime back. So hopefully this will now work. Yes. Another interesting thing actually about running it in Colab is they have got Gemini in here. So there is this, in theory, this AI help and support, which sometimes is useful, sometimes not. I was like, oh, what does this recommended plots do? So if I hit that, it thinks about it, and then it recommends some, not the world's most useful plots, I'm going to say. I think one of them is okay if it gives me any more. This date stolen versus count is actually useful, but the rest of them are just like, oh yeah, I'm not going to bother plotting that, but thank you for your help. But yeah, it might prove useful in some other ways.
Yeah, I like the year one on the x-axis. Is it starting at 0? We didn't have any cars stolen at BC.
Yeah. Yeah, we'll see in a bit that there are a few data points I can just about, it's really tiny. I don't know if I can zoom in. There's a few data points they're hanging at 0, but I'm just like, this is how they've grouped this is really not very helpful. I like this one as well.
So the Ford T was not the first after all.
Surprise, there's Kiwi ingenuity since the year 0. I'll just make sure these are all running.
There's actually a round rock that someone stole.
Some Flintstone stuff going on there.
Yeah. All right, where are we? I'm gonna load the categories. What I'm doing here is just oh, this is a long list. Go away. I'm gonna merge my vehicle categories onto my thefts, just so I can kind of do a quick check on like counts of cars and trailers without worrying about if it's a saloon or a hatchback, because I'm not really that interested. So I'm just going to do a quick check on how many rows have a missing category, which is a data set I've just merged onto. As you can see, there are a few. Largely this is because these are all missing a type. A lot of these rows look just real dodgy, like there's something was stolen in Auckland City at this point in time, but we have no other data on it. I'm like, that's great, thanks. Some of these ones we know enough about it to know what it is, but there's just, for whatever reason, there isn't a type on it. Apparently this is some kind of caravan, which is nice. A mini digger. Yeah, black box like in golf. Yeah, okay, we know what that is. This is some kind of like mini bike, I think, a farm bike. So there's a few things in here that, aside from telling us that something was stolen in this general region this time, is really not very helpful. And if you're trying to do data analysis on those data points, they just don't make any sense. So I'm just going to throw away all of the rows where there isn't a make or there isn't a type, because it is not helpful. I haven't put merged on the last line, so it's not printing me any output. It's just updated my merged data frame. If you are playing around with this at home, just have a dig around. There are some vehicles in here where the make is motorcycle or moped. That's not a make. I was also intrigued about what is mobile machine. I think they're largely like diggers and excavators and stuff, because people will steal anything. But yeah, we're gonna have a look at what's going on with these year 0 ones, because that is really odd. So apparently in the dawn of time, they were making trail bikes. Yeah. Presumably maybe the people just didn't know when these were actually built. So we just got 0, but it's not very helpful.
Well, maybe if we go all the way to the other end, we'll see that someone stole a Honda time machine or something.
You never know. I was like this. Oh no, that is a green mini bike. Yeah, I'm gonna leave these in this data set for now, because if we're looking at just kind of counts of make and models, they are useful. If we start doing anything with the year, it's gonna get a bit weird. So yeah, my final data frame. Yeah, nice. Gonna get into some data visualization stuff now, for which I've made myself a side quest, because I went to Kiwi PyCon the other week and I saw Stephanie Morland give a talk about her a project she's been working on called Datamorph. I don't know if you guys have come across the Datasaurus dozen before. But it is, do I have a picture here? Yes, here we go. A whole selection of different data sets that make up different pictures, including this lovely dinosaur. But the interesting thing about all of these data sets is if you're just looking at kind of the summary statistics, little bit like we were looking at before with like the mean, standard deviation, that kind of thing, the summary statistics for these data sets are all the same. So if you're not doing visualization, you're not going to be able to tell because they look the same, but they're really very, very different. And I love this concept. It also gives me a chance to demonstrate for Colab. Actually, I'm going to add a code cell here and do a Python -v so that you can actually tell what you're running. So our runtime is Python 3.10.12. This comes packaged with a lot of the usual packages that you might want to use if you're doing data analysis and data science. Like at the top, we've got pretty much some of the standard ones. NumPy-Pandas, Matplotlib, Seaborn, another visualization library, and then sklearn for some stuff that I took out of this example, but it's baked into the default runtime that they give you. But for this little demo, I actually want to include her package, which obviously is not included. So if I try to include this here, it's going to complain at me. It's like, oh, I don't have this module. And you're like, okay. So here I just said, if you're in Colab, because you're running this in Colab, then just do a pip install. This is like a just kind of magic method. So we can install this Datamorph AI package. And this will go off and find it and do all of the install. Similarly with the files, obviously this will put it into the runtime now. It's also telling me that I need to restart the runtime with the package. So I'm just going to restart my session. Up here it says restarting. And then what I'm going to do is do the thing that is now hidden off my screen. Yeah, runtime, there we go. Run before. Rerun everything, I can just watch this one. There we go. And now, hopefully, if I run this, done. Awesome, it's not complaining to me anymore. The other thing that I've done here, I am including just a little wrapper file I've written around her package, which lives over here. Oh no, I'll put it in util. Sorry, lives over here. Ta-da! A py file. And here I'm using just a couple of extra magic methods to auto reload. This is just because when you import the modules in this way, if you then go and change this file, you kind of have to like restart everything to get the changes, whereas using this auto reload, especially with auto reload 2, which just means it'll just kind of keep picking up the updates as you go. If I switch over to this file and change a bunch of stuff, I don't have to worry about like resetting and restarting my kernel. It'll just do it for me because I've said, hey, please auto reload this stuff. So that's also really handy when you are pulling in different modules. It's another thing that when you kind of build out, if you are working on like building out a model flow process or something, and you've got a whole bunch of data prep steps or a whole bunch of visualization steps that maybe you want to share with either other people or with other projects that you're working on, I always encourage people to try to make them like reusable methods or reusable modules that you can then just import into your notebook, so you're not copying and pasting everywhere. And that's kind of also where this stuff is really useful. So with this package, what is going on? She has written something where you can kind of specify, I'm just going to set this off running because it will take a little bit of time, and Colab version is really ugly. I'm sorry I couldn't get rid of these warnings. I'll show it to you in the local one, but she's written something where you have a starting shape and then a kind of ending shape, and then it iteratively goes through a number of steps, literally transforming one shape to the other whilst maintaining your summary statistics. I don't know why I just find this so interesting, but I do. I'm going to hide this because this is giving me hives, all of those warnings. But essentially in the background, it is, oh no, it is running. I'm going to stop this because that's just creeping me out now. Go away. But what I have told it to do is I want to go from this panda, beautiful panda. Here's the mean and standard deviations and the kind of correlation. And I want to go to the star, which has the same, exactly the same thing, but obviously totally different looking data frame. And then her package will also, it'll print out at each step what the image looks like and then make you this nice little GIF. She's kind of put it together as an educational tool, but I just really like it because it just really highlights, if you're not looking and visualizing your data, are you really understanding it? So yeah, it just tickles me, but that's just a bit of an aside. And also gives me a chance to demonstrate a couple of other magic methods that are available in notebooks. So I've obviously called this generate data morph example, which is out in another file. I could go and look at the other file and work out what it is, what its method call is. If I run this pinfo one though, on the side in Google Colab, I think it just appears in the normal output cell below in your local notebook, but it'll kind of tell you the signature for the method. So, you know, oh, it's expecting a data set and an output shape and an output directory for where to write these files to. I've been very naughty and not put any docstring in it, and this is where the method actually lives and what it is. You can also use these question marks at the end. So if you do a single question mark, I think it shows you the same thing as this. If you do this double question mark, you can actually go and have a look at the same thing, like the signature docstring, but then also the actual source. If you're like, you can't be, sounds a bit weird, you can't be bothered to go and like dig into this other file or scroll all the way up to your really massive notebook. You can kind of use these just to remind yourself, what is this method actually doing? Is it what I expect? Go have a look. So those are a couple of little helper methods that I find very useful. Back to data visualization. We have oh, I have already messed this up. Oh, I made it merge, didn't I? Sorry, I have changed this notebook quite a bit. I called it merged. All right. Let me scroll back down here. I'm going to cheat and just copy this into there so I don't need to change the other cells. So here we're just using actually just pandas with the plot method, which uses matplotlib underneath just to print out the different types ordered by how many there are in the data set. So obviously there's a collection of cars at the top. We'll do the same with the category. Yeah, cars predominantly going on here. People have a trailer as well. I guess they're quite easy to hook onto your tow bar and run off. Motorbike, and then yeah, at the bottom, kind of the more random ones, HV machine, that kind of thing. Matplotlib to me has always been just the interface for running that has always just been really hard, and I never find it all that pretty. So just got a couple of little examples of Seaborn. This is going to look very similar, but they have a simple count plot, so you don't need to do this group by and then get the size and then make sure the sort is good. And here we're going to look at the day of the week these cars were stolen or these vehicles. So yeah, the styling's much the same, but this method call and interface is much easier. What is a bit weird here is obviously we're used to looking at the day of the week in a certain order, and this is just, I think, picked based on when it's first seen a row with Saturday in it. It's gone a lot more fast. So we're going to tidy it up a little bit. I'm going to change the styling. So I'm saying, hey, use your white grid. I'm going to hue it on the week, is weekend or not. I'm literally just specifying the order of these columns and giving it a particular sort of color, and then also overriding the labels. I quite like this plot, but I think it's just purely a coincidence that it's turned out looking like this, where it's like everyone's really keen to go nicking stuff on Monday, so then they like lose enthusiasm a little bit, have a bit of a boost on Friday, and then chill out a bit for the weekend. I think that is purely just happenstance. Looking at the 6 months of data, I don't think that's really an actual story in this data, but it just made me giggle a little bit. What else am I looking at? Oh, I'm looking at a box plot. Here I'm looking at year, and I have forgotten that we have these year zeros, so we get an absolutely useless, like you can't tell anything from this. It's madness. So I'm going to take a subset of my data, just ignoring those rows where the year is 0, and then have a bit of a better look. I'm not keeping track of time at all, by the way, so if I'm rambling over, someone, for the love of God, stop me. There we go. At least we can see a bit better now. So yeah, these lines, if you're not familiar with box plot, you've got the kind of the mean in the middle, the 75% quartile, the 25% quartile. Based on that interquartile range is where it puts these kind of upper and lower limits, and then you've got the outliers here. So unless there was a data entry point, some poor person had their 1938-ish car stolen, which is really sad, but yeah, quite a few in the 70s as well. Big range in trailers, I guess. Yeah, Kiwis are well known for ingenuity and keeping things going, so there'll be a lot of those hanging around. So I think that was all I had on like the visualization and data analysis stuff. There's heaps of other things that if I was approaching this data set as an actual in an actual kind of work context where I need to derive some insights from this, there'd be loads of other things to look at, but it's just trying to give a flavor of kind of why this particular tool set is so useful for people doing this kind of like exploratory data analysis, or the POC stuff where you're building out models at the same time, just because it is so immediate feedback. You can see things that all through different stages of the code that you're trying to run, and you can also have this real rich visualization stuff baked in as well. I had another little bit at the bottom just with some other useful kind of magic methods that you might want to run. So you can use this percent time. This one will give you the time for this whole cell. I put in a very arbitrary sleep for 5 seconds, just so you can see here it says, yeah, wartime 501. You can also do time just a particular line in a cell. So if you've got something that is a bit slow, you're like, what is taking the time? And you can kind of test out different ones. Here I've got a for loop, but that's going to be pretty speedy. There we go. That's already given me the time, and then it's doing the sleep for 5 seconds. That's not included in this wartime. There's the who's, which kind of shows you all of the variables that have been set in this data frame, and a bit about what they are. And yeah, never super useful to print out like this module stuff, but in case you wanted a bit more detail about what is actually set in there, that can be useful. History will show you previous commands that you run. Literally with like the count of this, we've run like 2025. Oh, this can be useful if you have removed some cells and you maybe didn't mean to. You can either go and copy the content out of here, or you can use this recall method, which I'm not sure that this works so well in Colab, but if you are running it locally, no, that just tells me that. If I go back to my local one and run the same thing. Got a much smaller history because I didn't print out so much here, but if I say I want to do this 9 to 11, it actually pops out that content in this cell so that I haven't lost it to the annals of history, like I've kind of saved it, which is pretty useful. Yeah. One of the data scientists I work with has this habit of at the end of every notebook, he just prints out the time, so that if he's kind of saved his notebook with this experiment, and put it off in a folder with the output and come back to it later, he can always see like, oh yeah, I ran this 2 months ago or whatever, which I think is actually quite a nice habit and quite useful. Okay, I want to go back here. I'm going to change some things now because I do want to show you what this looks like when you're trying to use Git and when you're trying to do PRs and code comparisons. So I'm going to move to try to keep this nice. I'm going to remove this cell, put my imports up with the other imports so that we can always see what's going on. It is obviously standard practice in Python to have all your imports at the top, but keep doing that in your notebooks. And also if you have things that are like configuration options, I always like having those at the top so that it gives people an indication of things that they can change in the notebook that would lead it to behave in one way or another. So I am going to remove all of my output just because I can, and I'm going to save. What you'll notice here at the top as well, I've got a last checkpoint that says yesterday. If I save that, I'll just update it to now. So I'm like, yep, great. It's keeping track of my changes as we go. In the command line underneath, if you ever go digging into how this really works, there's like a .ipynb underscore checkpoints folder where it just kind of keeps track of these changes, and you can reset to like the last checkpoint if you want to. So I'm only sharing my browser, but what I'm going to do in the background is take that change and commit that and then push it up to my GitHub. You can listen to me typing, which is very unexciting for you. Once I prep this. And I just want to show you why some people don't like notebooks quite so much. Because they're used to a very, like they come from a coding background. And if you don't do certain things to make it a bit easier to look at the code changes, it can be very tricky. I'm just gonna push my changes. Then we'll go have a look at a dummy PR for this. Right, so if I go back here, this is going to tell me I've had test branch 2. Now I've clicked on something I didn't mean to, but if I go to pull requests, let's go have a look at what is happening in my test branch 2 with my world's most terrible commit name, whip. Please never do that. So in this example, I've got the .ipynb, which is kind of interactive Python notebook, I think is what that stands for. So I have changed a few things in this file. For this one, you're like, okay, yeah, I've removed some lines and that's fine. As you start kind of scrolling down, you start just seeing this like JSON stuff and the cell types and execution counts and IDs and like, oh, what is actually changing? Like it's really, you're looking at the underlying structure of the notebook, which is this JSON file where it's tracking the cells and the metadata as well as the content. Generally, this is not something as the developers that we care about. We want to see the actual code changes. So this just makes it noisy. It's like, this is the world's smallest change. Like I've removed a comment line, a couple of things in this, but already I'm like, what has happened? What's changed? So the easiest way that I found to kind of get around this is to use a plugin called Jupyter. If I go into my local notebook here, it's an extension to the notebooks. It's given me a new menu option here. And this has allowed me to also, when I save the notebook, the .ipynb file, I also get a .py file that uses a % format. So this doesn't have all of the messy JSON stuff, and it makes it a lot easier to look at. And I should have that included in here. If I go past, what I also committed when I was enthusiastically setting up this example pull request is in the intro notebook, the one that we first looked at, I didn't clear out any of the output. And so what I've ended up with here in this pull request is here's a like the print of a data frame from one of those output things, and it's just long and like generally you probably don't want that either saved in your source control, in particular if you're working at an organization and if you're investigating customer data. Like that's never a good thing to have customer data going into your source control. So the other thing that this Jupyter plugin will allow you to do is that because it's just saving the contents of the code cells in a different format, it's also not saving all of this output stuff. So you automatically, if you have your .ipynb file in your git ignore, which I don't obviously in this example, and you just commit those .py files, and you don't have to worry about ever accidentally like committing your customer data into your repo, because that is never great. Let me just close this IPYNB files. Oh, I think I've foolishly not added my .py file, but no big example into this change. Classic live coding. You can see a little bit though with this intro file, where I've literally just got the 2 cells that they've added. You can tell this is the like the % format, where I was printing out the D types and then I forgot how to code and was trying to do the describe thing, and yeah, live demo is not my favorite. But that is the difference with this file as opposed to this one, where I had with the output saving it, you're also saving this metadata of how many times has this cell been executed and all of this output. You don't have that, you just have this very simple one. So obviously when you have got a code change more fundamental than this one, like it's just way easier to see what's going on. Are there any questions at this stage? I've got another notebook just with the kind of few tips and things that I would think about when I'm doing notebooks, but I've kind of, this is the end of the looking at the actual running of the notebook bits. Otherwise I'll crack on. Okay, nice. The other one, yeah, say in this repo is just a notebook where I've kind of just listed out some things that I would think about with notebooks. I am always willing to get on my soapbox about documentation. Developers are never always super keen on writing documentation because it takes a bit of time. Data scientists may be marginally better, but they often forget that some people don't know like where the data comes from or what they're thinking about with a certain type of model. So if you're the engineer coming along to try to put this into production, you can lose a bit of that context. So yeah, I would always encourage you to add the sections at the top of the notebook, kind of describing what you're trying to do. If there's anything that you have missed, or if there are any particular gotchas on there, if it is a data thing, like just describe where the data's come from, and anything that might help with people picking up and using that notebook. So if it's a model that we're trying to like, here's a bunch of data and we train on it and then we put it into production, like how much data, what are the other things that we need to think about, and if there's any external documentation like linked to it. As you say, self-documenting code is a thing, but it just doesn't always describe like why you're doing something or other things that you might need to think about that aren't there in the code. Oh, why are you not doing that? Anyway, structuring the notebook. So I usually will try to break it down into individual, like specific sections. So here's a bit for like loading the data, doing a bit of data manipulation. Here's a bit for like data visualization. Here's the bit where I'm actually trying to build a little model and do some stuff. If you just have, if you can imagine with these just cells and cells of code doing stuff without anything breaking it up. And it goes straight away from like loading the data, changing it, doing some modeling stuff, someone else, or even your future self, because it's amazing when you look back at something you did a month ago and you're like, what is this? If you're trying to follow along with it, it can be really, just it makes it harder to follow. So breaking them down, putting in these like the markdown cells in between, just to give a bit of easy distinction when it decides to work. I think it's because I don't have any code cells in here. I think it would wrap up any cells after this one. It would let me collapse that. But yeah, breaking it up into sections, having the headings, so yeah, you can reduce that kind of scrolling and the eye overwhelm. And yeah, if you are then wanting to kind of look at methods in different points, using those magic methods to just kind of remind yourself like what the method signatures are and things like that can be really helpful. Similarly, if you're trying to, as I say, share some of this code between projects or between people, or you also are just trying to clear down what is in the notebook so you can focus on the main bit of the notebook that you want to focus on, pulling things out into external modules that then you can pull in is really useful for multiple reasons, but just kind of also in terms of decluttering, I find it really helpful. Some other stuff I said that people can get tripped up on is this whole concept of state, like because it's setting up these variables that then will live in the state for as long as the notebook and the kernel for the notebook is up and running. You can trip yourself up, especially if you've got a big notebook where you've changed something further down the bottom and then you're like, oh, I want to amend this method near the top, relying on the change you've made further down the bottom. You can just get in a bit of a tangle sometimes with the state. So always, before you're sharing, kind of just making sure you can run it top to bottom. It's really useful. I put in here because I don't like to use the word, but it does feel a bit more like hacky. You're not doing kind of, you don't feel like you're doing as proper code. Like it's not production ready stuff. You're not, I'm going to go off and read these things from AWS Secrets Manager or something. You're just going to pop an API key in at the top as part of your config, just so you can get up and running with your analysis or whatever you're trying to do. I just feel like it just can make it easier to accidentally start saving secrets. Then you start putting that into your GitHub repo. And then, yeah, that way is never a good way to go. The other thing that I have done is it can be very easy. Like if I want to close the notebook, closing and shutting down the notebook is where it will actually kind of shut down the underlying kernel for this. And I have sometimes changed a bunch of things, gone and closed and shut the notebook. It hadn't done an autosave and I hadn't hit save. And then it's not like, oh, you've got changes. It's just like, no, it just throws it away. So I've got really paranoid about always trying to like hit the save button so that it makes that checkpoint and actually saves it. This is also the point where if you have changed the settings in here, like this notebook tip one, I hadn't got it to pair with a % format because there's no code in this one. If I selected that and then I just closed the notebook and I didn't save it, it doesn't actually go and generate that py file. So that's just another thing to be aware of. As I say, yeah, for the code reviews, it's just can be very hard to look at if you're not using something like, oh, typo, Jupyter or I presume there are other options out there. It's just the one I happen to know and use and like. Yeah, it can be very painful if you don't have a way of just literally looking at the code bit without all the JSON madness. A note on like saving of the cell output. I've talked about obviously stripping out that output so you don't end up with it baked into your repo. You don't end up with customer data in there. But sometimes you do want to actually save the notebook with the output. Like if you're trying to share a notebook literally with the, here are the graphs and here's my explanation with the nice text and I want someone to go and look at it. I would say probably save that elsewhere. Like we have the joys of SharePoint at work, which is not my favorite thing, but I wouldn't save that still into GitHub, but you can obviously save it. You can download it. I haven't showed you that at the moment. You can do a save and export notebook as so many things in case you wanted latex or PDF. Or you can just like download it as an actual notebook file to send to someone else. Some people I know where they don't use Jupyter because they don't want choose that for whatever reason, but they definitely want to know that they always want to strip the output. You can just use like git pre-commit hooks for that if you just want to like make sure you're not saving any output, but you're not super worried about looking at JSON structures or anything. That is an option. A few extra notes just around getting code to production. I wasn't going to go too heavily into any of the more complex things around what we're thinking about in terms of like the actual getting an AI model into production or some of the more complex things that people can do with notebooks like scheduling, but I did just want to highlight a few things, which is just a major difference usually with Jupyter notebooks and production systems is the notebooks are running off static CSVs generally, especially if you're working with data scientists, because they want to know based off their static data set that all of the experiments that they're running and the models that they're testing and the analysis that they're doing is on an unchanging data set, because otherwise that makes it really hard if things are changing under the hood for them. When you get to production systems, obviously you're looking at API calls and databases and data that's streaming in and changing all of the time. So there's a lot of different things that if you are a person who's dealing with converting research code into production code, that you just need to think about on top of what the data scientists have already been thinking of. The last point is also similar to that. It's great in a notebook because you can kind of at every cell check that the output's what you're expecting, deal with any errors. Like if a value is a bit off from what you're expecting, you can be like, oh, that's a bit weird and shouldn't have occurred as a result of this particular algorithm. I'll go and have a look. But also when you come to productionizing it, everything goes into this big black box of AWS or Azure or whatever. So you have to have a lot of extra checks going on around your data to make sure that it is doing what you expect. The last couple of ones are things I have not actually ever tried to do. I just know you can do them, so I thought I would note these down. Is that you can schedule notebooks if you wanted to say like this one should run every night at 9 p.m. or every Monday. There are ways of doing that. There are things built into like AWSs of this world, like their SageMaker notebooks and their Cloud9 environments. Google Colab, you can do it if you have their Pro Plus version. They have different tiers which will give you access to more resources and more, I think they just call them work units, but also will let you do things like the scheduling of these notebooks. Same with systems like Databricks. As I say, it's not something I've ever done, possibly because I do come from a bit more of a software engineering background. So notebooks to me are like the playground where you test things out, and then when you want to do production, you kind of take things out and then have properly unit tested code and everything gets deployed in a proper way, and you're not having this this just kind of crazy notebook just going off and doing whatever it wants to every week. There's something to me about just having that unit tested code and having the separate stuff to the notebook just fills me with a bit more confidence. But it exists in enough places, I'm sure at some point you might want to do that, which is possibly also why people have built things that will help you do testing of notebooks. Obvious one that doesn't involve any kind of extra stuff is if you are having blocks of code that do any kind of like data manipulation stuff or anything else, if you extract them out of your notebook and you just import them into your notebook when you're using them for anything, this gives you obviously it's just a standard Python method. You can just unit test that as normal, and you're confident it's definitely doing what you want. If you ever do want to get into actual testing of notebooks, there's a few packages that exist out there. As I say, I haven't used them, I'm just pointing out that they exist. So Testbook is one example. I think it's fairly UI based, but you can kind of like run tests on individual cells or the whole notebook up to the cell under test if that sets up kind of dependencies that you need. Similarly, MBMake is another package that allows you to do the same thing. Some of these rely on you tweaking things like the metadata, which I didn't realize that you could do. So I looked it up, and here you can edit notebook metadata because we needed more JSON in our lives. So there's overall metadata for the notebook, but then each individual cell has metadata on it, and some of these packages lets you set things in here like this cell is expected to throw an exception, which I'm like, okay, that sounds great, but it also feels a bit hidden to me. So just, I don't know, having the confidence that it's definitely doing what you want. I'm sure you get used to it though, but just so that you know that is there. And yeah, some things are more run off kind of like UI stuff. So literally something that goes off, runs the notebook, and then literally inspects the output after it's there just to make sure it's done exactly what you think it has. Oh, I've been talking for a long time. I've realized the one thing that I haven't mentioned that I will show you quickly, and then I will shoot back into the chat and see if people have more questions, is that we've here looked at very much the Jupyter Notebook view of this. If you're running it locally, you see here there's a handy link to Jupyter Lab. If I click on that, this will open up the notebook in Jupyter Lab, which is very similar. In many ways, actually looks a little bit more familiar with Google Colab, which it is effectively running Jupyter Lab. As far as I can tell, I mainly, for no particular reason, just work with Jupyter notebooks, which just means each notebook is kind of a separate tab in my browser. I've got a separate file list. I do all my stuff command line anyway. I don't feel the need to have a built-in terminal, which Jupyter Lab will let you do. But essentially, this will let you kind of have multiple notebooks open under the same window. This integrated terminal that I'm now absolutely blanking on how to open. Like, you can get a list of terminals, workspaces. There's a whole bunch of stuff here. It's more of a kind of an integrated IDE environment as opposed to the individual tab ones for the notebooks. But essentially, it is doing exactly the same thing. It's just serving up to you in a slightly different way. I would generally just encourage you to go and have a play around and decide. As I say, I think it is mainly personal preference for how people want to run these. Yeah. If you did want to investigate more, as I'm going to leave my repo up there if you want to have a play around with all of the mad things that Kiwis have decided they want to steal in the last 6 months, to go for it. If you open up Google Colab and you see this page, they have a whole bunch of example notebooks as well that you can play with. Obviously running the kind of systems underneath, but there could be some interesting things here to just kind of play around with and get a feel for. Also on Kaggle, which if you've not looked at it before, is like a site for data science stuff. They have like competitions and you can go and try and like build models and all that kind of stuff, but people also share their notebooks that they've created. So you can go and kind of, if you do code and search, you can go and have a dig through notebooks. And a lot of these, I haven't actually opened this, but they will be pretty annotated and will describe what they're doing at each stage. So they're also kind of quite a good resource to go and have a look at to get more familiar with notebooks. I'm going to stop talking now, but yeah, does anyone have any questions off the back of all of that? It's a lot of information, but
No, it was great information. And Deanne was worried that we wouldn't have enough content with your contribution to fill the time. This is
he
great.
doesn't know how well I ramble, so
We love a good ramble. So any questions for Alex that's come to mind? Difference between Jupyter Notebook and Jupyter Lab, Dan asks, question mark. And what is the difference? Jupyter Notebook.
yeah, essentially, as I say, it's just kind of the Jupyter Lab one is just a bit more of an integrated environment. Like it's more familiar. For the data scientists, if they're using R, they have this thing called RStudio. It's more familiar for people with that. Like you can have multiple tabs with multiple notebooks in this kind of same window. So it just lets you jump between them much better. I don't use it a lot, which is why I'm kind of like, oh, how does this work? Oh, yeah, here we go. It is essentially, though, the same thing. Oh, there's even a handy link there. What's this? Enable debugger. But it just kind of lets you do more things in one place. Yeah. As I say, they literally kind of do the same thing. It's just personal preference as to how much you want to have other things going on, or if you just kind of literally just want, I just want my notebook with my things. I don't want to worry about, can I easily access a terminal at the same time? More of an IDE, I guess, for developers as Jupyter Lab. Yeah, sorry, I don't have I probably don't have a better answer than that, to be honest.
Is it somewhat more shareable, perhaps?
I don't think so, because essentially it's the same thing. You end up with these notebook files. Kind of like the output is the same, it's just how you're interacting with it is different. Yeah.
Well, great. Yeah, it looks like our crowd has dwindled a bit, and I think we've handled all the questions. So thanks again, Alex, and thanks again, Deanne, for setting this up. This was a great presentation. We should have a recording out soon and on YouTube. We also have a recording from the past meetup that is in process from James Powell. I believe he's on something of a speaking circuit right now, so not pestering him too much with that just yet. But yeah, Alex, great stuff. That was awesome.
No worries. Thanks for having me. It's been good.
All right. Well, have a good one, everyone, and we will see you in a month. Ta-ta for now.
Thanks.
Thanks, Woody. Thanks, everyone.
Thanks, everyone. Right.